The Lockheed Constellation was one of the most important aircraft in the rebuilding of the airline industry after the war. Often described as the Queen of the Skies, it was the most powerful and advanced airliner of its time. A combination of many technical innovations came together in a true success story. In addition, the distinctive curves of the fuselage and the perfect balance of the design made the plane a thing of beauty and grace. Large four-engine transports are not always aesthetic, but the Connie's lines demand admiration. The Constellation was the pinnacle of piston engine transport design and broke new ground in both its civil and military variants. However, its career overlapped into the jet age, and the appearance of the new technology brought down a premature curtain on its lifespan. The Lockheed Company, with a heritage stretching back to 1913, had painstakingly built up a reputation for constructing excellent and trustworthy passenger aircraft. Commencing with the Vega and following up with the Orion, Lockheed's reputation blossomed. They became associated with the famous names of aviation between the world wars. Wiley Post and Amelia Earhart both flew Lockheed aircraft. The list of records set in Lockheed planes grew rapidly. The company products were not simply a successful reworking of the day's technology. They were innovative and influential. Lockheed had a succession of talented designers. Jack Northrop was followed by Gerald Vultee. When both of these men had gone off to found their own companies, Lockheed retained the services of a team led by the greatest engineering double act in aircraft history, Paul Hibbard and Kelly Johnson. Lockheed developed an excellent family of fast twin-engine transports in the Electras and the Lodestar, carrying between 10 and 14 passengers in what was, comparatively, only moderate discomfort. In 1938, Howard Hughes piloted a Super Electra around the Northern Hemisphere in just over 3 days and 19 hours. Hughes' respect for Lockheed was cemented, and later he turned to the company in trying to fulfill his aviation ambitions. The flight of over 14,700 miles confirmed a view held by many, including Hughes, that civil airliners would be the mass transit method of the future. And to do this, the individual plane would need to carry many more people over much longer range. Lockheed had already been working towards this with their Model 44 Excalibur, designed to carry 36 passengers. They were more than receptive when Hughes approached them on behalf of his airline, TWA. He had a clear idea of what sort of plane he wanted and what it would be able to do. His basic specification was an aircraft that would fly a payload of 6,000 pounds from New York to Los Angeles non-stop in 8 to 9 hours. It would be a 4-engined pressurized luxury airliner cruising around 300 miles per hour. TWA had set the parameters for capacity and performance, but it was the Lockheed team which designed and built the plane. It drew on many successful elements of their earlier studies. The wing was expanded from that of the P-38 Lightning fighter. The triple tail, originally designed by the Douglas Company, had been tested in the Model 44 project. Kelly Johnson was intimately concerned with the new project. Here, the wind tunnel camera catches him changing the shotboard in one of the long series of model developments. Because the plane drew so much on the work done for the Model 44, it was initially referred to as the Excalibur. However, it acquired a new number, the Model 49, and soon was given a new name as well, the Constellation. Lockheed's main rivals had been leapfrogging each other in airline development, with Douglas reaping the majority of the rewards in America along the way. However, they did not have a client with the determination and checkbook of Howard Hughes to support them, and their designs were transitional rather than attempting one giant step. Lockheed had conducted a lot of relevant research and development during the 30s, and this had equipped it well to approach the new design. The company had been involved in pressurization experiments with the Army. An Electra had been modified for the tests and given the Army designation of XC-35. The plane first flew on the 7th of May, 1937. With the information derived from these tests, Lockheed were able to devise the Constellation system. This maintained cabin pressure at ground level up to 9,000 feet and restricted pressure to that of 8,000 feet when the plane was at 20. The XC-35 was, in effect, a practical advantage that Lockheed held over their rivals. In a similar way, a lot of the expensive development of the wing shape had already been born in the design of the Lightning. Even with these advantages, the cost per Constellation quoted to Howard Hughes was, for the day, astronomical. Hughes' determination funded the development from his first meetings with the company in June 1939. However, progress was slow. Many design problems needed to be overcome in reaching the stage where production could commence. Perhaps because the company had not built such a big aircraft before, Lockheed's team were very flexible about their approach. The series of decisions that set the Connie's shape serves as an example. Large engines working at low revs were less likely to feel stressed and break down. So, a combination of such engines with large propellers was suggested. The large propellers demanded absurd ground clearance and a very long forward undercarriage. To shorten that wheel strut, the nose is bent down. The large area of disturbance from the propellers suggests the triple tail will not work in flight. However, a more efficient single tail will not fit into a hangar. The solution? Curve the fuselage upwards and take the triple tail out of the propeller turbulence. The plane that results has a straightened S for a centerline in the side view of the fuselage. And it works. As a bonus, it's also beautiful. The first Constellation went not to Howard Hughes Airline, but to the United States Army Air Force. War had swept up the US, and civil aircraft production had become another arm of the war effort. Wartime pressures delayed the Constellation further, but eventually, on January the 9th, 1943, Project 49 took to the air for the first time. The first plane was the production prototype. There was no transitional model. Existing commercial orders had been drafted even before the US entry into the war, and by 1942, the Army added orders for 300 of the type, most with a more powerful engine. Now, being military aircraft, the first Constellations were given a military number. They became C-69s. The test series was delayed due to trouble with the engines, and the first plane was not handed over to the US Army Air Force until July the 29th, 1943. In the time the plane was grounded, Lockheed and TWA took the opportunity to repaint it and do some publicity shots. Some of the testing was also conducted in TWA livery and used for publicity. This was nothing compared to the publicity coup pulled off by Howard Hughes with the second machine. The plane had been delayed in production and made its first flight only in 1944. It was accepted by TWA on behalf of the military on April the 16th, painted in TWA's colours, though showing its military serial number. The following day, the plane took off with Hughes himself at the controls. It flew non-stop from Burbank to Washington, a distance of 2,300 miles, in the record time of 6 hours, 57 minutes. This was an average speed of 330 miles an hour, a respectable speed for a fighter of that era. In addition to the successful publicity for Hughes and TWA, the event spotlighted the Constellation, to the mutual delight of Lockheed and the Army. After the record flight, the plane was kept in Washington for a week of displays and inspections before being delivered to the Army. Over the next 18 months, the C-69s were to make a number of significant long-distance flights and set a series of records. These included successive transatlantic records, reducing flight time to Paris to under 10 hours. It was evident that the Army had found in the Constellation a valuable personnel transport. The C-69 could carry up to 64 fully armed troops, or alternatively was capable of transporting a light tank or other medium vehicles. The underworked big engines returned excellent fuel consumption figures and combined with the plane's range, speed and capacity to put the Constellation far ahead of its competitors. While this was not that relevant in 1945, it would be a telling advantage for Lockheed at war's end. Even though there was a clear need for cargo planes, the Army never placed a high priority on Constellation construction. Under Army direction, Lockheed concentrated on production of other warplanes. In addition to its own Hudson and Lightning designs, the company was heavily involved in construction of Boeing's B-17. Most of Lockheed's experience with four-engine planes during the war was with the Fortresses rather than the non-belligerent Connies. Lockheed produced many thousands of aircraft during the war, but only 22 of them would be C-69s. Army orders for hundreds of C-69s were never fulfilled. Only 15 had been delivered when the war ended, with another 7 planes almost completed. In addition to Lockheed's production being directed to other types, the Constellation used the same engines as the B-29 Superfortress, and few of the power plants were allocated to the program. The engines had teething problems, and a shortage curtailed production. Testing was disrupted, with frequent groundings of all types using them. At war's end, 12 of the 15 planes delivered to the Army were declared redundant. All military orders were cancelled, and Lockheed paused to consider their options. The decision was made to go ahead with the Constellation as the company's primary product in the anticipated post-war expansion of commercial travel. While their competitors tried to rebuild bombers into airliners or upgrade their pre-war designs, Lockheed were ideally positioned with a tested and proven aircraft that was very advanced in comparison to any other type available. By buying back C-69s from the Air Force, including those partially built at the factory, Lockheed were able to offer customer airlines new aircraft almost at war's end. Pan Am were the first to receive these refurbished Army planes, and the Connie made its first commercial flight on the 3rd of February 1946. 3 days later, TWA introduced its Constellation service, first on the transatlantic route, and then a month later commencing transcontinental flights in the US. Competing carriers were mostly relying on DC-4s, and the Connie had no problems outperforming the older Douglas plane. The efficiency of the Constellation was undeniable, and within 2 years, TWA's rivals on the transatlantic route had been forced to change to the Lockheed plane themselves. In effect, the Lockheed decision gave them an 18-month lead over their competitors at Boeing, Douglas, and Republic. This was clear to the airline operators as well. Within a week of the war's end, the company had orders from 8 airlines for over 100 Constellations. The contracts totaled over $75 million and allowed Lockheed to retain its skilled workforce as production of the Connies was stepped up. The original batch of ex-military planes was soon used up, and new examples started to roll from the factory. Though intended for civil use, they were still the basic C-69 as ordered for the Army. The plane had reverted from its military designation to the Lockheed project number. Thus, the basic aircraft was referred to as the Model 49. During the war, Lockheed had advanced 5 further studies for improved Constellation variants, and these were given an extra numeral, the first being Model 149, the second 249, and so on. One of these projects had been for a long-range bomber variant of the plane, but the other 4 were all transport versions, 3 being improved civilian airliners. There were 73 civil Model 49s, including the recycled C-69s. Their immediate availability after the war gave Lockheed the time to refine the Connie further before releasing the first truly civilianized version. For some carriers, the purchase of Constellations propelled them into the big league. KLM was one. As early as November 1946, they had transferred their transatlantic route to Lockheed Model 49s, and the Connies served the airline well from then into the mid-50s. By that time, KLM was a major world airline with a massively expanded network of routes. Work on what was to be the first civilian production model had begun in May 1945. This was the Model 649, developed in conjunction with Eastern Airlines. Among the many developments introduced with this model was the SpeedPack external cargo bay. This was another example of the Lockheed team's lateral thinking. The Connie offered little cargo space when laid out for maximum passenger carriage, but had power to spare. To avoid cutting back on the number of passengers, additional cargo space was bolted to the outside of the plane. This increased goods carriage by 8,000 pounds at a penalty of only 10 miles an hour in speed. The model also introduced a new and more powerful version of the engine, rated up to 2,500 horsepower. The 649 first flew on October the 18th, 1946. It was a notable advance on the Model 49 in many aspects. Major improvements had been made to soundproofing and cabin air conditioning, giving a far more pleasant ride than any other airliner at that time. Eastern began to advertise their planes as the Gold Plate Connies. They began operating services in May 1947. Overlapping with the deliveries of Eastern's 649s came another new version, the 749. This had been developed as a long-range model for overseas operation, based closely on the Eastern aircraft. The outer wings contained additional fuel tanks which added a further 1,000 miles to the range of the plane. With this version, the New York to Paris route could be flown non-stop. Further improvements to the 749 were recognized with the sub-designation 749A. Air India was the first to employ these, bringing them into service beside earlier Connies they'd purchased. The improvements made to this version were directed to obtaining a higher gross takeoff weight, bringing an addition of nearly 5,000 pounds to the payload. The weight of the Connie had grown markedly during her career to that time. The initial C-69 had a maximum weight of 72,000 pounds, but this had been expanded to 107,000 with the 749A. At the same time, the range had increased from 2,400 miles to well over 3,000. Many of the improvements made to these planes were later built into earlier models, blurring the distinctions between the early versions. The Constellation stood at what was to be the pinnacle of propeller-driven airliners. The technology of the propellers themselves was very highly advanced. With its fully reversing blades, the Connie could pull itself up on landing in a very short time, or could back itself into a parking bay. The props could also be fully feathered to reduce drag if an engine cut out. Extreme use of the reversing props on landing produced this sort of spectacle, with the Constellation not only coming to a halt in a very short strip, but promptly backing up. The Connie's props had been carefully matched to the huge engines chosen for the plane. The big blades caused some problems with undercarriage in hoisting the plane clear of the ground, but these problems were offset by the advantages gained in flight. The big engines were run at very low revs, with no stress and minimum fuel consumption. They were quite capable of keeping the big plane aloft, even if two were to cut out, and even if both of the engines on one side had to be shut down. By setting the plane to demand so little of its power plants in normal operation, Lockheed built in an enormous reserve. The 749A specification had originally derived from renewed military interest. The original C-69s had been a problem aircraft for the Army, due in no small part to the experimental nature of the design. The Army was well served by its large fleet of Douglas DC-4-derived C-54s and abandoned the Lockheed plane. But when, in 1948, the new US Air Force turned its attention to the Connie, it was no longer a new design that pushed the state-of-the-art under wartime handicaps. This time, the Air Force bought a minor variant of a well-proven airliner, as the C-121A. Two were immediately redesignated as VIP aircraft and allocated to General MacArthur, who transferred the name of his old C-54, Bataan, and General Eisenhower, whose plane was known as Columbine. Later VIP Connies were assigned to Eisenhower after he became president and were named Columbine II and Columbine III. The non-VIP C-121As were used as cargo and personnel transports and had strengthened floors and large rear fuselage cargo doors. Over the next few years, the original Air Force order of 10 aircraft were all reconfigured as VIP planes. The first was delivered in December 1948 and the last in March 1949. They soldiered on for nearly 20 years of service and were not retired until the late 1960s. The return of the Constellation to Air Force service was followed by interest from the Navy, and a new military role dawned for the plane. The C-121's career was to be very long and very influential, and redefine the military use of large transport aircraft. By the time of Columbine III, President Eisenhower's plane was a much different proposition from his first Constellation. In the development of this new type, the story of the Constellation returned to its beginning, to the first C-69 built. This had displayed its military number, 310309. However, its company number had been 1961, and it was as old 1961 that it was to gain its individual fame. During the war, the first Constellation had served its share of Army duty. During this period, it was re-engined with Pratt & Whitney radials as an emergency-driven response to the chronic problems with the Wright double cyclone engines. After this refurbishing, the Army took to calling it the XC-69E, though it was otherwise unchanged at the end of hostilities. It was then put up for sale and bought by none other than Howard Hughes. In 1949, he sold it back to Lockheed, and a transformation began as it was turned into the prototype for Model 1049. The most obvious change was that the plane was stretched. Two new sections of fuselage were built into it. One section before the wing added 10 feet 9 inches, and the second, behind the wing, 7 feet 8 inches. The alteration was so radical that the company marketed the plane under a new name, the Super Constellation. TWA had again been involved in the development of the plane, but Eastern Airlines had lodged its actual order first, and so they received the first Super Connies. In addition to the obvious lengthening, there were many other improvements. A better de-icing system for the wings, stiffened wing surfaces, increased fuel capacity, and more powerful engines were all incorporated. The gross takeoff weight of the plane increased by only 12%, but such was the efficiency of the design that payload increased by 40%. Seating was available to cater for between 69 and 109 passengers, as Lockheed devised a variety of layouts. Some were designed for long-range carriers and others for commuter airlines. Other plans with fewer seats catered for routes with a higher proportion of freight or allowed the removal of the fittings to use the aircraft as a part-time cargo plane when passenger traffic was light. The company's intent was clear. The Constellation had given them a captive market they did not want to lose. The new planes were assembled in Lockheed's appropriately named Hall of Giants. The first version had only a limited lifetime. It had been intended to give it a new and revolutionary turbo-compounded engine, but teething problems with the new power plant had led to the use of standard, though uprated, radials. The 2,700 horsepower delivered by these engines left the Constellation slower than its rival, the Douglas DC-6, and only 24 were built. Lockheed were forced to persist with introduction of the more powerful but underdeveloped new engines. Though problems persisted, the strategy paid off and sales picked up. With the introduction of the new engines, the plane received a further 20% boost in its weight-to-range ratio. All comparisons with the opposition were addressed, and orders resumed their earlier, hearteningly busy frequency. This beneficial change was in part forced on the company. They had had enough of unproven engines earlier in the Constellation's career. However, the military were very interested in an uprated Super Connie, and much less so in the underpowered original model. Not only did the re-engineering rekindle civilian sales, but the new Super Constellations were to be the test bed for a revolution in military aviation. Today, the concept of aerial command posts, electronic surveillance centers and radar stations is commonplace. They've proved their worth time and again during their short career. Most of the experimentation that proved their effectiveness was conducted in Constellations, as was most of their early service. Again, old 1961 was involved in making aviation history, as with domes above and below, the original plane was used to trial the installations. The first Connies constructed as airborne radar pickets were built for the Navy. They replaced earlier rudimentary installations aboard converted World War II bombers. Aboard the planes, a crew of 22 were involved, with aircrew, radar operators and engineers. With their long range coupled to the search range of their extensive load of equipment, these Navy WV-1s proved the worth of the concept and installed it as an accepted part of naval practice. Soon, the idea spread to the Air Force. The Air Force had placed orders for Super Connies for use as conventional transports, but C-121s would not be delivered as such until 1956. Before any transports could be built, the Air Force acknowledged their better use as airborne early warning aircraft and changed the order for the first 10 to its own flying radar pickets as RC-121Cs. These planes, loaded with 15,000 pounds of radar equipment, would cruise at 335 miles per hour for up to 24 hours on patrol. The RC-121C was similar to early Navy Super Connies, with their height-finding radar housed in the 8-foot tall hump, and the bearing scanner located in the ventral dome. The RC-121Cs entered service in 1953 and were mostly employed in patrolling the western seaboard of the USA. They were followed in 1954 by the first of an order for 72 RC-121D Warning Star aircraft. In addition to the passive role of detection, these incorporated offensive activity as control centers for the guidance of fighter interceptors. From the basis of the Warning Star, a number of options presented themselves. Once the idea of putting equipment into aircraft was digested, there was a rush of ideas about which equipment might be suited to the treatment. Advanced electronics and surveillance types multiplied. As the transport planes appeared, they were often pulled back to the factory for refit as one or another of the electronics versions. The appetite of the services for these valuable aircraft was insatiable. Over 220 of the main types alone were built, disregarding the one-offs and the small runs. Most of these planes were also completely re-equipped at least once in their lifetime. Between the Air Force and the Navy, over 25 different designations were used to identify versions of the radar-equipped Connies and their control center brethren. In addition to proving the concept and paving the way for their successors, these constellations also performed very real service in an era when there was no other practical solution. At the height of the Cold War, when hostility and distrust often combined in equal degree to form policy, a calmer picture of reality was maintained by these electronic eyes in the sky. In 1962, the RC designation was changed to EC, and the electronics Connies were to earn their later Vietnam fame under that designation. They were a pivotal factor in US defensive strategy and had become as important as the cargo-carrying versions were dispensable. Despite using non-standard fuel and requiring piston engine maintenance that was an almost dead art form, the Connies were nursed along. Old age and technological redundancy could not undermine their essential functions, and some were to remain in service until the early 1980s. Their longevity was helped not only by their expert care, but by the excellence of their original design and construction. The jet age was, however, drawing in on the Constellation's career. It was obvious that the introduction of jet airliners would change the whole market expectation, and Lockheed were determined not to be left behind. Aware of the limitations of early jet technology, they set about refining a system of compound engines, or jet props, using jet engines to drive propellers. They'd already extended the piston engine by the use of turbines driven by the exhausts. These had added 20% more power to the engines, and were the peak of piston engine development. Employing a jet and prop combination was designed to extract maximum economical efficiency from both technologies. Once again, the test bed for an aviation milestone was old 1961. In its last major notable achievement, the venerable airframe was fitted with an Allison turboprop in the outboard starboard position. This engine couldn't save the Connie, but it was part of the foundation of one of Lockheed's most successful aircraft, the C-130 Hercules. It was also at the heart of the successful Lockheed Electra, which kept the company alive in the civilian market. However, for the Constellation, its success as the pinnacle of piston-engine airliners somehow acted against anyone taking a jet-powered version seriously, even though the finest development, the Starliner, was yet to come. With a new wing shape and other major revisions, the Starliner carried Lockheed's hopes of continued dominance of the long-range airliner market. However, though orders for Super Connies didn't dry up immediately, there was no flood of orders for the new plane. Only 44 of this vastly improved version were built, and most were phased out of service relatively quickly, being replaced by jets. The improvements made to the Starliner were numerous, and it was undoubtedly the finest piston-engined airliner of all time. But it was too late. Lockheed's enterprise, imagination, and innovation continued to work around the Constellation, and several refinements, including the now familiar revolving antenna, were developed and tested with Connies. The new development of the Starliner gave Lockheed a new proposal to put to the Air Force, and the company invested considerable time and money sorting out the best package it could develop around the plane. The revolving dish was only one of the systems developed for the submission. With turboprops, extended range, specialized layouts, and a large number of new features and improvements, the Starliner was being prepared for what would be the next sales opportunity. By then, the success of the airborne radar and control planes demanded that a fleet of such aircraft be maintained. The aging C-121s would need replacement. By the time the competition was announced, Lockheed knew that no matter how excellent their proposal was, they didn't really stand a chance. Hard on the heels of the formal call for tenders came the specifications, and these confirmed Lockheed's fears. Time had stolen a march on the military Starliner, as well as the civilian version. The Air Force was not just in the market for a replacement for their Constellations. To be more precise, they were in the market for a jet-powered plane. The Boeing company had the world's best such aircraft on its catalogue, developed for the Air Force as a jet tanker, the KC-135. The result was a foregone conclusion. However, the appearance of their replacement did not signal the end of the Connie's military career. Whereas the arrival of Boeing's jet had seen the quick demise of civilian Constellations, the Air Force and Navy were content with the capabilities of the plane, and coincidentally, they had need of them. The first USAF C-121s to be based in the Asian theatre arrived in Thailand in April 1965, although Navy planes had been the first Connies involved, starting with missions in August 1964 at the time of the Gulf of Tonkin incident. The Constellations flew throughout the war, and their service was invaluable. They performed in a number of functions, some of which were developed and tested as a response to the armed combat raging below and in the air around them. The big plane's commodious fuselages saw many refits. The variety of Constellations deployed to Vietnam illustrates the way the big planes had taken on so many roles for the services. Their main work was as airborne early warning aircraft, but they were also used for a number of other missions. A few cargo versions were used, primarily for aeromedical evacuation and as passenger planes. However, beyond that, the specialist electronics planes filled a number of roles. One of these was the relay of data from sensors scattered along the North Vietnamese supply routes as part of Operation Igloo White. To have diverted the jets to these tasks when they were needed as refueling tankers would have been highly impractical, and the Connies, available and reliable, soldiered on. The Constellation's original deployment to Vietnam was essentially defensive. They were to be used to provide a radar picket to guard against North Vietnamese bombers attacking targets in the south. However, this proved to be a short-lived need, and the duties that kept them in the theatre were over a broad spectrum. One of the most unusual roles the Connie was called on to perform fell to this plane, an NC-121J of the Navy's Development Squadron VX-8. The designation was given to a group of planes that were variously modified to secret specifications. There was no conformity within the designation. It was, effectively, a grab bag for various one-off Connie versions. This plane, for example, had its own special fit and its own special mission. The equipment fitted to this plane was definitely non-standard in military terms. These 2-inch tape players were the ultimate in professional television formats at the time. The duty of the aircraft was to serve as a television and radio broadcaster for the armed services networks. By hauling the transmission aloft, the service was taken out of range of Viet Cong interference. Ground-based transmission would have required infrastructure which, as a tempting target, would have needed constant guard. The quietly plodding Constellation transmitting from on high made the maintenance of service broadcasts practical. Of course, most of the Constellation activity in Vietnam was far more actively involved in the conflict, with the most important work being performed in monitoring the North Vietnamese. As soon as operations over the North began, the Constellations became essential factors in the struggle. As the war went on, their role gradually evolved from passive to active involvement. Operating over their own ground, the North Vietnamese MiGs were given very accurate information about the whereabouts of US aircraft in their airspace. This advantage was at first simply countered by the operations of the US radar planes, which were able to relay similar information about MiG activity to the American strike aircraft. As the war went on, the Connies increasingly assumed a more active role, making direct contact with American fighters and guiding them in attack on any North Vietnamese activity. When the North became better equipped with missiles, the Connies were able to fix the location of any SAM site radars that were operating. This served two purposes. It warned aircraft in the area to expect trouble, and it led the Iron Hand weasels to attack the sites. The last Constellation operations in the theatre were flown in May 1974. Well after the last operational strikes by US forces, the big observers continued their monitoring. By then, it was 25 years after the first electronics refitted Connie had so impressed the Navy. It was also 31 years after the first Constellation flight. When the Constellation was at its peak, the axe fell. They were forcibly retired from service long before they wore out. The major airlines were forced, partially for reasons of prestige, to abandon props. The Connies had been the key to the establishment of long-distance civil traffic after the war, but business has no place for soft sentiment, and they were abandoned quickly. By the early 60s, the civil career of the Constellation had moved to small airlines and lesser routes. There they continued to work for many years. Gradually, they became relegated to cargo, and then lingered further as isolated crop dusters and fire tankers. The military career lasted much longer, with the last Navy Constellation being retired in June 1982. The last Constellation built had been delivered in 1958. 856 Connies were made in 16 years of production. Their career stretches from World War II to the space shuttle. They were, throughout their career, used as test beds for a multitude of developments. The results of this service are still seen in use in both military and civil aviation today. One of the most beautiful aircraft ever produced, time reduced their worth to their weight in metal. Very few escaped the scrap merchants, and now they're treasured museum pieces.